Good morning, everyone. My name is Ridwan. Welcome to Soft Code Math Academy. In this channel, we always talk about Python programming, Java, and mathematics. So today, we are talking about laws of indices under mathematics. So when we are talking about laws of indices, we have many laws. Sometimes some people do ask that, okay, do I need to follow the order? Yes, most of the times it is very important to follow the order in which we have all the laws. Why? Because when we start from the law one, the one that we call law one, law two, law three, by the time you are moving higher, you will be implementing some of the previous laws in the subsequent one. So that's why it is very important to follow the order. So let's start. So let's say law one, whenever we have something like x raised to power a multiplied by x raised to power b, then it will be, you pick one of the x, then because we have multiplication, the two power will be added together. That is, it will now become x raised to power a plus b. A very simple example here is, in fact, I want us to take note of something. Here, I will just introduce us to some of all these laws. In the subsequent videos, please kindly subscribe so that whenever I upload any video that is related to either mathematics or Python or Java or anything you are interested in, you'll be notified. Thank you. So, as I was saying, in this video, I will introduce you to most of all the laws. So, in the next video, we now do what? We now start solving so many problems, both from the basic up to the advanced part, so that we can see the full implementations of all these laws. Thank you. So, now, here, let's say we have something like x raised to power 3 multiplied by x raised to power of 2. So, it will now become, by implementing this law, we pick one of the x, then we have this power of 3 plus 2. So it will now become x raised to power of what? 5. That is the final simplification. Okay, let's say the second example here. Let's assume somebody asks us to simplify something like this. Mind you, we are using x here. We are just using x as what? As a general definition. It is not necessary to be x. We can be asked to find something like to evaluate 3 raised to power y squared multiplied by 2 raised to power y multiplied by y raised to power 3. Can you see that? This will now be, in this case, please, you have to look at this very well. The first thing you have to treat is all the coefficients of all these terms. The coefficient of y squared is 3. Coefficient of y here is 2. Coefficient of y raised to power 3 here is 1. So we have to multiply all the coefficients first. 3 times 2, 6. 6 times 1. That is going to be 6. Then you can now pick one of the y. Then you can now add the power. 2 plus the power of y here is 2. The power of y here is 1. The power of y here is 3. So it will now become 6y raised to power 2 plus 1, 3, 3 plus 3, that is 6. And that is the final simplification. Beautiful. Now let's go to the next law. Now we have been told that wherever we have something like x raised to power a divided by x raised to power b, please mind you, take note of this. This I have here is the same thing. I can write it as x raised to power of a, this division, then raised to power of b. Am I communicating? Now, whenever we have either this or this, then the result will be x raised to the power of what? A minus b. Let's take note of that. Then example here is this. Let's say we are to simplify x raised to the power of 5 divided by x raised to the power of 2. Look at this, everybody. Before we implement the formula, that's law 2, I want us to observe something here. Somebody can say this is going to be x raised to the power of 5, okay, divided by x raised to the power of 2, which is very correct. Somebody can now say that because I have x raised to the power of 5 here, it will now be x multiplied by x multiplied by x multiplied by x multiplied by x. Can you see? Because of raised to the power of 5 in 5, then divided by what? X multiplied by x. Now what will happen? 1x will cancel 1x, good. 1x will cancel 1x, fine. We now have x times x times x. The result is now x times x times x. Beautiful. Now everybody, if I now implement that law 1, so it will now become x raised to power here is 1 plus power here is 1 plus power here is 1. It will now become x raised to the power of 3. But this is too long. This is too stressful because here the powers, they are not big. Imagine we have x raised to the power 20 divided by x raised to the power 2. Is that how we now split x raised to power 20, it will be too stressful for us. That is why we are now going to use the formula. We now say our x raised to power what? 5 divided by x raised to power 2 will now be what? X raised to power 5 minus 2. It will now give us x raised to power of 3. Beautiful. That is the law 2. Now let's go for the the third law. So let's go for the third law now. Now, law 3. This one says that anytime we have something like x raised to the power of a raised to the power of b, the result will be x raised to the power of a times b. That is, this power into bracket this power. So it will now be a times b. Example here, if I have something like y raised to the power of 2, everything raised to the power of 3, that's going to be y raised to the power of what? 6. Another example, let's say this Roman figure 1. If I have something like 3 raised to power 2, then raised to power 2. This will be 3 raised to power 2 times 2, okay? And this is going to be 3 raised to power 4. That's what? 81. Are you with me? Beautiful. Okay. Then another law states that, just similar, the one that is similar to this one, if I have something like m divided by n, everything raised to power of p, this one will now become m raised to power p divided by n raised to power of p. That is, we are going to do what? We are going to distribute this power over numerator and denominator. Example here is, if I have something like, if I am to simplify x raised to power, let's say x raised to power 2 divided by y raised to power 3, then everything raised to power 4. Beautiful. This one will now become x raised to power 2, okay, raised to power of 4 divided by y raised to power what? P, then raised to power of 4. This will now become x raised to power of 2 times 4. If I use this formula, can you see? This law 3. So now be 2 times 4, that's what? 8. Divided by y raised to power what? 3 times 4. 12. Simple as that. Are we getting it? Beautiful. Then, let's go for law 5 now. So don't forget, everyone, please kindly subscribe to my channel so that subsequent videos you'll be notified. Okay, let's go to law 5 now. Now, everybody, let's look at this law 5. We have been told that if we have x raised to power 0, the result will be 1. But x must not be equal to 0. Please don't be confused, everybody. This is what they are saying here. They are saying that, example, Roman figure 1. If I have 127 raised to power 0, the result will be 1. That is, what they are saying is, any value of x raised to power 0, the result will be 1. But that value of x must not be 0. Are we together? Beautiful. So, another one here is, imagine if I have something like 1024 raised to power of 0. The result will still be 1. Funny enough, even if I have something like this, let's say I have minus 3, everything like this raised to power of 0, that will be what? That will still be 1. This is different from if you have something like minus 2 raised to power of 0. This one will become minus 1 times 2 raised to power of 0. This one will now be minus 1 times what? 1. And the result will be minus 1. Please take note of this one, though, so that you will not think that minus 2 raised to power 0 like this. It is only when everything is inside the bracket like this, that of number 3, this Roman figure 3, that the result will be 1. But what? Now, here x is 127 raised to power 0, we have 1, follow the law. Here x is 1024, which is 1, follow the law. Here x is minus 3 raised to power 0, follow the law. Here x is what? 2 raised to power 0, but we are now multiplying by minus 1, then we have this. But what if x is 0? You now have 0 raised to power 0. This is not equal to 1. Please take note of this. This is not equal to 1. Okay, that is the meaning of this condition. Okay, that is good. Now let's go for another law. Okay, so let's call that one law 6. Now this law states that anytime you have something like x raised to power minus 1, this will be 1 all over x. But x must not also be equal to 0. Can you see that? Why? Because if x is 0, 1 over 0 is undefined. It is indeterminate. It's just like this 0 raised to power 0. This one too is undefined, or we can say indeterminate, okay? So, now, example here is if I have something like 3 raised to power minus 2, this will become 1 over 3, or better still, let's say 3 raised to power minus 1. This one will become 1 over 3 raised to power what? 1. That's 1 over 3, okay? Let's say 5 raised to power of, if I can even say something like this, look at this. If I say 5 all over 5 all over 3, okay, raised to power of what? Minus 1. It will now become 1 over, in this case now, 5 over 3 is now x. If you follow this law, since x raised to power minus 1 is 1 over x, so in this case now, 5 over 3 raised to power minus 1, our x is now 5 over 3, it will now become 1 over x. It will now be 1 over 5 all over 3. And if you simplify further, this means 1 division 5 over 3. Okay, this one I can also write it as 1 over 1. It does not change anything. I will now say 1 over 1. If you transform division to multiplication, then denominator will come to numerator. You interchange this. That's 3 all over what? 5. It will now become 1 times 3. That is 3 divided by 1 times 5. That is going to be what? 5. It's as simple as that. Okay. Now let's go for the law 7. Okay. Now for the law 7 now, everybody. So we have what? Let's say we have something like x raised to power is just like a general terms of law 6 of minus e. The result will now be 1 all over x raised to power of a. Am I communicating now? So that if I have this example, for example, let's say we are to simplify 5 raised to power minus 3. This will be 1 all over 5 raised to power of 3. Okay, and that's going to be 1 all over 5 times 5 times 5. Okay, and that's 1 all over 25 times 5. That's 1, 2, 5. Am I communicating? Okay. Now, law 8. Law 8 says that if I have, look at this, if I have something like nth root, this is called nth root of x raised to power m, then the result will be x raised to power the power divided by this n. Okay. Example here is if I have something like, let's say I have something like cube root of y raised to power 2. I can write it as y power 2 divided by this 3. Good. Another one, I can say that, okay, what if I have square root of x raised to power 5? So this will become x raised to power what? The power 5 over what? 2. Okay, this is 5 over what? 2. Please, just take note of that, okay? Now, so we have that, isn't it? Now, let's say we already have this. What if I have something like this, everybody? What if I have something like, let me call it Roman figure 3 under that. I have something like, this is a fourth root of x raised to power what? Minus 3. Are you with me? This will now become what? If you follow that law, it will now become x raised to power minus 3 divided by what? Divided by 4. If you want to simplify further, you will use one of the previous laws. It will now become 1 over, that is anything that is ahead. It will now be 1 over what? X raised to power what? 3 all over 4. Just like this law 7, x raised to power minus a is 1 over x raised to power of a. That means in this case, our a is 3 all over 4. Are we getting it? So this is the final simplification. So another one that we can say, that we can call that one law 9, is just like when we have an exponential equation, something like if x raised to power a is equal to x raised to power b, then the bases are equal, x here, x here. Therefore, the power also will be equal. A will be equal to b. Example here is, let's say we have something like 2 raised to power of, let's say x is equal to 8. Then after we should find the value of x. What are we going to do? We will find, this is the smallest value. We will find the way we can express it in terms of power of 2. And that is what? 8 will give me 2 raised to the power what? That's 2 raised to the power 3. 2 times 2 times 2. I will now have 2 raised to the power x equal to what? 2 raised to the power 3. Beautiful, because 2 raised to the power 3 will give me 8. We have not changed anything. I can now compare the two. The bases are equal. This base and this one, they are equal. Therefore, by implementing this law, x will now be equal to 3. Beautiful. We can even confirm now because we said that 2 raised by x is equal to 8. From the left hand side, I substitute 3 for x. If you put 3 here, 2 raised by 3, what will it give you? It will give you the one at the right hand side. So that is that about that. So in the next video, I will do what? We now start solving so many examples. We are going to solve a lot of examples in that video. So kindly subscribe and stay tuned. So, but before we go, let me give you this exercise. Okay, exercise. So, if you can plot the result, if 1 all over 2 raised to power x is equal to 32. Okay, find the value of x. Find the value of x that satisfies this equation. Okay, see you guys. Kindly subscribe. Thank you.